So today, what we're going to start by doing is looking at a typical exam question. But before we even start looking at this question, I want to ask you a question of my own. I want to know what type of graph is the graph F? And I want everyone to put it in the chat. So what is the graph F that we're going to start with today? So we've got two graphs, and I want to get some feedback from the people of the room. Okay, so the graph of F is a parabola. Yes, you guys are winning. Winning. And the graph of G, what is the graph of G, or the green one? Okay, the green one is a straight line. So when we look at graphs and we have interpretation, the two characters that are involved are the parabola and the straight line. And we can kind of see this visually over here. Now, there's some important labels on the graph. You can see A, C, E, D. These are all capital letters, and they're talking about specific points. Now, I want to ask, before we do 3.1.1, what is special about A and B? What is special about A and B? Because they say here we have to find the coordinates of A and B. What do you notice about the points A and B? And someone could put their hand up if they know the answer, or they can put it in the chat. What do you think is special about the points A and B? Take a moment to look at the graph. So a couple of different answers. Keep those answers coming. So they're on the same axis, and they on the y-axis. They're on the y-axis. Yes, absolutely. X value is 0. It's another comment that's been made. They sit on the y-axis. Yes. Does anybody have the sort of official sounding name for A and B? What is, they're on the y-axis? Yes. What's the special word? We would say that A and B are the y-intercepts. Yes, A and B are the y-intercepts of the graph F and the graph G. Now, to start with today, I want you guys to try and find me the coordinates of A and B. Now, again, for those who are completely new, we are building on previous lessons, but let's just give it a go. And then once you've had a go, you can put your answer in the chat, or if you're willing to share your answers, you can pop your hand up and you can tell me what the answer for 3.1.1 is. Over to you guys. So just to begin, A and B, what's special about them is they're both y-intercepts. They're where, like A is where the graph F cuts the y-axis, and B is where the graph G cuts the y-axis. So A and B are both y-intercepts. Now I want you to try and find me what the coordinates of A and B are, the y-intercepts. I'm going to wait for someone to put their hand up or to put the answer in the chat. Okay. Okay, so I'm looking in the chat. I'm seeing some students starting to put answers there. Now, there's no guarantee they're right. So remember, be comfortable putting your own answers in the chat. And if you're willing to share, just put your hand up and we can unmute you. And audio-wise, it might be even quicker than having to type it out. So for A, which is on the parabola, students are saying that A's coordinates are 0, 3. And I agree with that. But I'm going to ask students how they got that in a moment, but that is the correct answer. Now for B, students are saying in the chat 0 minus 1, which I agree. Can anybody put their hand up and tell me how you got them so quickly and easily? What did you do to find those points? Is anybody willing to put their hand up and let me know? Or you can put it in the chat if you want, but how did you know how to get that? What did you do? Okay, so Tabiso has said, I made x equal to 0. And so if I did that here in F, if I made x 0 here, that would be nothing. That would be nothing, and I'd be left with my 3. And that's why I have the 3 here. And Annie has said the same thing. And for this graph, we say we make x 0. And if we make x 0, and that's how we get the y-intercept, we make x 0. Then what's left behind? It's the minus 1. And that's why we have that. Okay, now I want you to, next question is, I want you to find me the length of AB. So we need to know how long is this distance AB. Put your answer in the chat. Okay, so how far is it going to be to go from here, which is 3, and that's at minus 1? Well, you have to go 3 to get there, and then another 1 there. And so the answer is 4 units. Cool. All right. That wasn't too hard. Now you have to find for me the coordinates of C and D. Now, before I let you go off and do that, what is special about C and D? What makes them, like, what club are they part of? What do you have to be to get into the C and D club? Any ideas? They both lie on the x-axis and they're both x-intercepts. They're the x-intercepts of the graph F, or the parabola. Now, in order to find the x-intercepts, what do we have to do? What's the golden rule we need to use to find x-intercepts? This goes from our lessons we did about drawing graphs a while ago, but you have to make y equal to 0. Yes. So I want you to find me, oh, look at all those awesome answers. Feliciwa and Bali and Zanele, Mesh. So if you want to find the x-intercepts, you make y 0. Okay, over to you guys. Solve it for me. So there's two ways you could do this. The one is the formula, the other one is factorizing. But what are my final answers going to be? What am I going to get for C? What am I going to get for D? So yeah, the X cuts seem to be X is 3 and X is 1, but now we need to decide which one goes with which letter. Now C looks more to the left to me. And so because it's more to the left, C is going to be 1, 0. And then D is going to be 3, 0. Give me a thumbs up if you understand why C must be 1 and why D must be 3. I just want to check you understand why I knew that. And Mbali and Zanele, you're completely right. I see your answer there. Okay, now it looks like we're all okay. Now what we're going to do is we are going to try and find the intersection points of F and G. So I'm going to change this question. 3.1.4 is going to be to find the intersection points of these two graphs. Now, if I look at the graph, I actually know one of the intersection points already. What is the one that I can just see straight away? What is the intersection point in this graph of the two graphs, just looking at it visually, using the working out we've done so far? It's going to be C, exactly. We know that C is the point 1, 0. So that's one of the answers to the intersection point. But I want you to find me what F is. And F is an intersection point between, or F, the capital letter is, maybe someone can put in the chat, how do you find, or maybe someone can tell us audibly, how do you find intersection points? What do you need to do to find the intersection points of two algebraic functions? I'd love to hear it either in the chat or audibly. Someone explain to us what we need to do. How are we going to find that intersection point? Let's have a look in the chat here. Equate the functions to each other. Yes. So if you want to find an intersection point, all you do is equate the two functions. And in this case, you'll have x squared minus 4x plus 3 should be equal to x minus 1. And using that, I'm going to give you more time. I want you to figure out what the point F is. Mesh says solve simultaneously. You're absolutely correct, Mesh. You're absolutely spot on. And so if I equate these two, now I have to solve it. And that's what you're going to do. And then when someone's got the answer, they can just let me know. So I'm trying to figure out what this point F is. So when you try to solve a quadratic equation, you have two choices. The one is to try and factorize it. For a lot of you, though, using the formula will be probably more reliable. It's up to you to decide what tool you want to use, but both ways will give you the same answer. Now, to get what F is, we still have a bit of work to do. It seems like the X values I'm getting are 1 and 4, and that makes me happy because I know that C has an X value of 1. So that makes me happy. I'm on the right track. So now I know that this value here is 4, but that's not the whole coordinate. I need to find out what goes with the 4. Who can tell me how I find what goes with the 4? What do I need to do to figure out what goes with the 4? Because I think F has an X coordinate of 4. That's what we got from here. But I need to figure out what the Y value is. Who can give me an idea? What do I need to do to get the matching Y value? So you substitute the 4, is what Morgan and Tando are saying, back into either of the original, and G of X looks the easiest. So if I said, what is the G of 4? It's 4 minus 1, which is 3. And so F's point should be 4, 3. So it is indeed in line with that. Give me a thumbs up if you're following what I've done there. Give me a thumbs down if you're feeling a bit lost from the pace at which we're going. Just want to get a feel for the tempo in the group. How are we all doing today? Okay. Fantastic. Be honest, eh? Honesty is the best policy. All right. Now, 3.1.5, we have to find the coordinates of the point E. But before we do that, what is special about the point E? I want some feedback from the class around what makes E special. What's like its special name? What's its characteristic? And how might we get it? So the feedback from students is that E is the turning point. How would we find that turning point? How would we find that turning? There's two ways we can do it. I focused on one way when I helped you learn how to draw these graphs, but there's E is the axis of symmetry. So well, E's X coordinate will be the axis of symmetry. But I want to know, how do we get it? Like, what do we need to do to actually figure out what E is? I see it's worth 3 marks. Interesting. So there must be some work in there. Does anybody want to give us a tip? Or should I suggest a method? Think back to when we learned how to draw parabolas. What was step 4? Yes, Mbali and Zanele. Okay. You have 2 ways of doing this. The one is to look at the parabola standard form, and you use the formula minus b over 2a if it's in standard form. And so in this case, it would be minus 4, because I'm taking the b there, over 2 times 1, and that gives me 4 over 2, or just 2. So the x-coordinate of E is 2. The other way you could have done it is, because this is the axis of symmetry of this graph, the turning point will always be halfway between the two roots. And if you go 1 plus 3, you get 4. And if you divide that by 2, you get 2. So both ways will give you the answer 2, halfway between the two x cuts, or use the formula minus b over 2a. Now I want to know what is going to be the y coordinate that goes with E. That's the next part. What is the y coordinate of the point E going to be? So it's like, I know that E is in line with 2, but I want to know what y value. So I think I just need to put it back into the original equation to figure out what it is. So the original equation, I want to know what is the f of 2. And the f of 2 will just be 2 squared minus 4 times 2 plus 3. So can you see I'm using this, and that is going to give me 4 minus 8 plus 3, which is going to give me minus 1. So it's minus 1. Yeah, we're doing some quite hard questions here. So it's actually in line with B, that point there. All right, last 2 questions, and then we're going to have a break. Now, this is where they get exciting. Give me a thumbs up. Actually, maybe it's not the best way to ask it. But generally speaking, students find these types of questions a little bit sneaky. So let's do them together. For what values of x is x squared minus 4x plus 3 greater than x minus 1? Now, what this is saying is it's saying for which x values is this formula is the f function. So when is f greater than g? So for what x values is f, the function f, greater than g? And what another way of saying this is, when is f above g? So let's have a look at this graph. It looks to me like when we start, if we look at this graph, it's way above the straight line graph G. And it stays above the straight line graph until I get to C. Then it goes below the straight line, and it stays below the straight line until I get back to F, and then it goes above again. So when we ask this question, we're saying for which x values is the parabola above the straight line? I'd like to give you a chance to try and answer that question. So I want you to think about which x values are going to be appropriate. And I'm going to start you off by saying you definitely want to include this bit to the left here, because it feels like it's definitely above there. But what other areas are going to be included for 3.1.6? So is there any other method for finding the turning point? There's 2 methods, Mesh. The one is to say the turning point will be halfway between the 2 x-intercepts to find the x value of the turning point. The other way of doing it is make sure your parabola is in standard form and then use the formula minus b over 2a. Okay, so let's get back to 3.1.6. We know the value of c, so x must be less than 1. That is going to be the one part where this is true. The other part where this is going to be true is going to be that part over there, because the moment you go past x is 4, the f is above g again. And so how are we going to write that down? So when x is less than 1, the parabola will be above, and also when x is greater than 4. And that's where f is above g. Okay, last question before the break. For what values of x is f of x less than 0? Now, when we say f of x is less than 0, we're actually saying when are we below the x-axis? So we're talking about the function f. The function f is the parabola. And this question is saying, when is its y value less than 0? And I think that if we look at this picture here, it's almost like it dips below in this little region here. And I want you to write out what you think the answer is to describe that region, that green region there. Type it in the chat or let me know, how would you describe that inequality, that region? That's the only place where f is below 0. I'm waiting for those lovely answers to pop in. So it's not going to be 2, because remember, I'm describing for what values of x. I want to describe the green region here. So how would I describe that region? So normally, you would say x is greater than 1, which is the endpoint there, but it doesn't include the 1 here, because the question said, where is it less than 0? So it has to be only greater than 1 and less than 3. The moment you're at 3, you're actually equal to 0. I want to be less than 0. But as long as you can see that answer of x is between 1 and 3, then you are golden. Now, we've just done a 17-mark old exam question. So there were some tricky questions in there, but let's just get a little vote from the public. Thumbs up if you felt like you followed that. Thumbs down if you're feeling a bit lost now. Okay, awesome. I mean, I'm pushing you guys now, but this is good because you're starting to get a solid base in functions. And don't worry, mesh, that's perfect. Minus b over 2a is the x value, and then the 4ac over 4a is just what we get when we go back into it. All right, now we're going to do another question like this after the break. For those students who are feeling confused, don't worry. We're going to do another one just like this, and then we're going to build up to this one. Okay, but first we need some exercise. So I want you to be standing up with me. I want you to get some space. And I want you to start by making yourself like a licorice and just moving around. And move your arms around like you're made of jelly. And then shake your legs around like you're made of jelly. And
please turn on your cameras, guys. Let's see your lovely faces.
I want to see the people of the room. I want to see that I'm not the only crazy person out there. There must be other crazy people out there too. Okay, let's stretch our necks. There we go. Oh, that's a good click. Stretch to the other side. And then I started doing this last time. Try and find somebody on the other side of your room and look into the distance so your eyes get a chance to relax. So you zone out your eyes. And I'm just looking to the other side of the room so that my eyes can relax instead of focusing on the screen the whole time. So just look into the distance a bit. And then let's roll our shoulders. Roll our shoulders back. Roll our shoulders forward. And then stretch out like this. And then stretch out to the other side. And then swing the arms a bit. Let's do a tricep stretch. There we go. Other arm. There we go. And then stretch up to the sky. Oh my goodness, I'm getting tight. Okay, then let's do some heart rate. Let's do skipping, virtual skipping. We're going to do 20 virtual skips. Make sure the space is clear and let's go. 3, 4, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so our little break concludes itself. let's just do one little Maths 24 puzzle just to keep it interesting. So who would like to give me the answer to one of these Maths 24 questions where you have to try and make 24 using any of these? Well, basically you must use the 4 numbers. And can you make 24 using plus, minus, times, and divide? Who feels like they can give me the red one? So Tando, 1 times 4 times 4 plus 2 doesn't quite get there. 4 plus 2 is 6. Yes, there we go. Okay, so I think the most popular answer that I'm seeing so far is 4 plus 2 times 4 times 1, which gives you 6 times 4, which is 24. Or some people are saying 4 plus 4 gives me 8, and 2 plus 1 gives me 3. And so that can also give me 24. Awesome, awesome, awesome.
Nicely done, guys.
You guys are becoming naturals at this. Okay, well, time for round 2. So we've really got to the level of kind of past exam questions here. And we're not going to do all of them, but I'm going to choose a couple. So I just want you to see like you're already at the exam level. So question 1, find for me the f of minus 3. Find for me the f of minus 3 by looking at this question from a past exam paper from the Department of Basic Education. What does it mean to say the f of minus 3? We can see that f is this function here. But what does it mean to say the f of minus 3? What's my answer going to be? It seems to me like the f of minus 3 says I must put minus 3 inside the function f. So I think what I'm going to have to do is I'm going to have to say this is minus 3, and then minus 3 plus 2 is minus 1. I have to do a little bit more algebra here. Minus 3 over minus 1 is plus 3 plus 1, which is 4. So the f of minus 3 is 4. Okay, before we move on to the next one, so the correct answer is 4. And this is a hyperbola. So this type of function f is a hyperbola. I want to know from you in the chat, what type of function is the g of x? Before I move any further, what type of function is the g of x? Let me know in the chat. Look at those answers flying in there. Thank you, Mish. Thank you, Neo. So this is an exponential function. And the reason it's exponential, we know it's exponential, is the variable is in the power. Okay, so that's good. We've recognized it, whereas this one over here was a hyperbola. Now, here's the question. It says, determine x if the g of x is equal to 4. Now, this is different to the last one. The last one said find the f of some value. This says find x if g of x is 4. Now, I'm wondering, can someone help me understand where I start with this? What is my first step going to be? I know it will be connected to this graph up here, but how am I going to start this? This is where I'd love someone to, even if you get it wrong, hearing it through your words is very helpful. And so who thinks that they know where to start with 1.2? Where would I start with 1.2? I'll give you some time to try it by yourself, but because we're a team together, see if you can share where we start. Aha, so Mbali and Zanetta said the g of x is the same as saying let y equal 4. And so what I could do is take this, and where there's a y, I make it equal to 4. So I say 4 equals 2 to the minus x minus 4. And now I have to solve this equation to find the value of x. That is fantastic help. But now you need to kind of go and find me that x. How am I going to find that x? Well, normally when we solve equations, we try and get the x by itself. And so that's a good tip to think about. Like if I bring this minus 4 across, I'm going to get 8 equals 2 to the minus x. And now it feels like we're in the land of exponential equations. So we say, well, we need bases to be the same. So we get 2 to the 3 equals 2 to the minus x. And then we can say 3 is basically, if the bases are the same, we can then say that 3 is equal to minus x. We can basically just drop the bases because they're the same. And then to get the x by itself, I divide by minus 1 on both sides, and x should be minus 3. There we go. Awesome. Awesome, Conker. Awesome. And Phyllis. Now, we've got a feel for this. We know we're dealing with a hyperbola. We know we're dealing with an exponential. The next question is, I want you to try and write down for me the asymptotes of f. What are the asymptotes of the function, the hyperbola? Now ask yourself, what is an asymptote? An asymptote is a line that the graph gets closer and closer to, but never crosses. And how many asymptotes are there for a hyperbola? There are actually 2 asymptotes. Now, I want you to tell me in the chat, what are the asymptotes of f? So for 1.3, the one that I can always see straight away, because it causes it to be undefined, is that x is equal to minus 2 is the one asymptote. That will be the vertical asymptote, because you can see that it makes division by 0, and that causes the asymptotes. And then the other one will be y is equal to 1. And so that will be my 2 answers for 1.3. So it'll be y is equal to 1 and x is equal to minus 2. Okay. Next question. And please do, if I'm going too fast, it is important that you either raise your hand to ask a question or put a question in the chat. So for example, now I've got one. How did I get the minus w? Maybe Zoom user, if you could, how did I get the minus 2? Oh, okay. To get the minus 2, I looked at what would cause division by 0 in f. And if x is -2, then -2 plus 2 is 0. And so that would cause the division by 0 is what causes there to be undefined on the graph, the asymptote. And so that's how I got my 1 over there. And then the other asymptote just comes from here, comes from that +1 there. Okay. Find me the range of G. So now the range concerns the Y values. For what Y values am I going to be in between here? I'll get rid of some of this. Okay, this is a little bit sneaky. Part of me almost wants to know where the, in order to know the range of G, we're dealing with an exponential. Does an exponential have an asymptote? I think it does. And the exponential graph's asymptote is this -4 over here. So in order to do the range for G, I almost feel like I need a little sketch graph to help me. And so I'm going to put y equals -4 over here. So we know it can't cross that, but here's the problem. I know that it can't be there, but I don't know if it is on this side or if it's on that side. Are you with me on that? Give me a thumbs up if you understand what the question I'm asking. I'm saying, look, I want to find the range of G. I'm looking to understand, I know that it's undefined here, like it can't go here, but the question is it on this side or is it on this side? And the reason I ask that is there's a -x here. And so normally an exponential graph would look like, say, like that, and then it will be shifted down and look like that, let's say. That's what normally happen. But the problem is that it's 2 to the -x. And if you think of the last lesson, what does it do when you change the sign in front of the x? It reflects it over the y-axis. Okay, the y-axis. And so the y-axis, that would be fine. It's just going to look, if it was going like that to start with, it's just going to look like this. And so we're fine. The range, it doesn't actually affect anything. Okay, so maybe I have freaked some of you out a little bit. Apologies for that. But all I was trying to show you is that this -x will reflect it over the y-axis. But in this case, does that really affect, does that affect what side it's on? No. So look, judging by this drawing, what is the range of this graph going to be? It's just going to be all these values over here. So can you write down the answer for that for me? So I'll give you some time. I just want to quickly connect one of my cables to my. There we go. So how would we describe this range over here? Who feels like they know? Isn't it just going to be y is greater than -4? So I'm just trying to describe this region here. The range talks about the y values. Okay, I'm going to go over this again. So let's see what the stuff that we understand. Are we all happy? Give me a thumbs up if you understand why there's this dotted line for the -4. It comes from over here. Okay, now, are you happy that the graph should be on this side of the line and not on that side of the line. So are you happy that it's on this side? Give me a thumbs up if you agree with that. Okay, so now what's going to happen is this graph is going to get closer and closer to -4, but never get there. But all the y values of this graph are going to be above that -4. So for example, like this point over here, it's going to have a y value there. This point over here, that's going to have a y value there. This point on the graph will have a y value. So all of these y values are in the range of the exponential. So that's why we say y is greater than -4. It's above that. Okay. Now, what I want you to do next is I want you to try and find me. There's not going to be enough time for doing both. We're just going to find the y-intercepts. So the last question for today, can you find me the y-intercept of the function f? Can you find me the y-intercept of the function f? And then we're going to call it a day for today. How do we normally find the y-intercepts for these things? So we're dealing with f. And for the y-intercept, I need to make x 0. So I actually want the f of 0, don't I? So the f of 0 is just going to be -3. So I'm going in there and I'm saying 0 plus 2 plus 1, which gives me -3 over 2 plus 1. But now I want the y-intercept. I suppose that's fine. You know, if you wrote it as a coordinate, it would be 0 minus a half. But it actually only says find, oh, it does say the coordinates, determine the coordinates of the y-intercept. So it's 0 minus a half. Yeah. All right.